Hello everyone. In this video, we'll discuss about Coulomb force and its applications. This is a part of electric charge and fields class 12 physics syllabus. And in this, first I'll give you statement of Coulomb force. Force of attraction or repulsion between two charges is directly proportional to product of the charges and inversely proportional to square of the distance between them square of the distance between the charges. So if two charges were separated by distance, suppose Q1 is one charge, Q2 is another charge, they are separated by distance R, force between them is directly proportional to Q1, Q2, then force is inversely proportional to R square, or else we can write like this: F is equal to some proportionality constant 1 by 4 pi epsilon naught Q1, Q2 by R square. This 1 by 4 pi epsilon naught will represent with K, whose value is 9 into 10 to the power of 9 Newton meter square per Coulomb square, and its dimensional formula will be like this: Newton means mL t power of minus 2 meter square L square by Coulomb square ampere square times square. So its dimensional formula will be m L cube t power of minus 4 a power of minus 2, and here epsilon naught is called permittivity of free space. Epsilon naught is called permittivity of free space, whose value is 8.852 into 10 to the power of minus 12, and its units will be Coulomb square per Newton meter square. So its dimensional formula will be m power of minus 1, L power of minus 3, t power of 4, a square. And here we will define one more definition like dielectric constant or relative permittivity. Relative permittivity will represent with epsilon r, that will be epsilon by epsilon naught. This is permittivity of the medium and this is permittivity of the free space. And for a good conductor, epsilon r value will be infinity. And you can expect some graph based questions here, as F is inversely proportional to R square. Graph between force and distance, rectangular hyperbola. And vector form we can write like this: vector form of Coulomb's law, that will be F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square into R cap, where R cap is the unit vector along line joining the two charges and this R cap is given as R bar by modulus of R bar. So we are having certain properties for this Coulomb force. It always acts along the line joining the two charges. Line joining the two charges. So as this force, it can be attractive or repulsive. In both the cases, it will act along the line joining the two charges, and it obeys inverse square law. Obeys inverse square law. And Coulomb force is a conservative force. Means work done is independent of path. Work done is independent of path and obeys vector law of addition. Obeys vector law of addition. That means F bar will be equal to, suppose we are having more than two forces, or then the resultant force we can represent like this, or it obeys principle of superposition. Then using our parallelogram law of vectors, we can identify that net force as square root of F1 square plus F2 square plus 2F1 F2 cos theta. And the direction of that resultant, we can use this equation. Tan alpha will be equal to F2 sin theta by F1 plus F2 cos theta. So if you know these two equations, we are having, if the two forces are identical, we can use that also in some cases. If F1 is equal to F2 is equal to F, then this F net will be equal to 2F cos theta by 2, and tan alpha is equal to tan theta by 2. That implies alpha will be equal to theta by 2. These formulas are very useful while solving some numericals. If identical forces are there, we'll use equation 3 and 4. If the forces are different, then we'll use that equation 1 and 2. So now we'll solve some examples based on this simple formula. Just look at this example. A charged object is there. Its charge is Q. It was divided into two parts. Suppose one part is having charge Q and the other part will have charge Q minus Q. Now they are separated by certain distance. Suppose one is Q1 and the other one is Q2. They are separated by certain distance R. Now Q1 is Q and Q2 is Q minus Q. So they'll ask you to find ratio of Q by Q such that force between them is maximum. So if they ask it like this, what is our force formula means? I'll write K Q1 Q2 by R square, or from this F will be equal to K Q1 is Q, Q2 is Q minus Q by R square, or else I can write like this, F is equal to K by R square into Q minus Q square. So now as force has to become maximum, dF by dQ must be equal to 0. So if I differentiate this, differentiation of q is 1 minus 2q, that will be equal to differentiation of q square is 0 2q, so that will be equal to 0. So from this, q by q will be equal to 1 by 2. That means we have to divide that charge into two equal parts, then only the force between them will be maximum. And sometimes they'll ask you this kind of questions also. Just look at this. Find ratio of electrostatic force to electrostatic force means that is Coulomb force to gravitational force between two protons. Between two protons. They asked like this. So they are asking electrostatic force to gravitational force ratio. What is electrostatic force means K Q1 Q2 by R square, by gravitational force means G M1 M2 by R square. So that from this, as R square gets cancelled, we'll have K value as 9 into 10 to the power of 9, and Q1 charge of proton 1.6 into 10 to the power of minus 19 per 2 times, and G value 20 by 3 into 10 to the power of minus 11 into mass is almost close to 10 to the power of minus 27 kg, and this is also 1.67 into 10 to the power of minus 27 kg. So if we solve this, this will be approximately 10 to the power of 35 you will get. So electrostatic force is stronger than gravitational force. Okay. Now, this is another example. Already this example we solved in previous video also. A and B are initially having same amount of charge Q and Q. Another neutral body is there, C. Three are identical. C is first kept in contact with A, then QA will be equal to QC will be equal to Q plus 0 by 2. It will be equal to Q by 2. Then the same C we brought in contact with B, so that charge on B will be now charge on C will also change. It will be Q by 2 plus Q by 2. It will be 3Q by 4. So now QA is Q by 2, QB is 3Q by 4. Initially both are having same charge, so that if suppose the initial force, if both the spheres are separated by distance r, initial force will be simply kq square by r square. They'll ask you to calculate final force. That final force will be equal to k qa qb by r square, or I can write like this: k by r square into qa q by 2 qb 3q by 4, or this will be equal to 3 by 8 times k q square by r square, so that force decreases by 3 by 8 times that of the initial value. So this kind of questions also you can expect. And the next example is like this. If suppose there is an equilateral triangle and there are three charges at the three corners, all are identical, and as it is an equilateral triangle, all sides will have same length. This is A, this is also A. Find net force on charge at any one corner. I want to identify, I'll assume this has first charge, this has second charge. I'll try to identify net force on the charge at the third corner. As both are identical charges, force due to 2 on 3 will be like this, and force due to 1 on 3 will be like this, and F1 and F2 will have same magnitude, which will be kq square by a square. But as it is an equilateral triangle, if this angle is 60 degrees, this angle will also be 60 degrees. As the two forces are identical, net force, as I gave that formula, it will be 2F cos theta by 2, or that will be equal to 2F is kq square by a square, and cos 60 by 2, that will be cos 30, which is root 3 by 2, which is root 3 k q square by a square. That is net force. If they asked for direction, alpha will be equal to theta by 2, so that will be 60 by 2, which is 30 degrees. That force will act in this direction, resultant force at an angle of 30 degrees. So this kind of questions you can expect. And one more example based on the same equilateral triangle. If suppose they give one charge as a negative charge and the other charge as a positive charge. Suppose this is negative charge and this is positive charge, and charge at this corner is positive. So now this first charge will give attractive force and the second charge will repel this. This is the F2, this is F1, and magnitude wise same, but the angle will now become 120 degrees. So in that case, net force will be 2F cos 120 by 2 cos 60. Cos 60 is 1 by 2. 2F into 1 by 2, or that is F, which is kq square by a square. And of course, direction, if they ask for identical forces, alpha will be theta by 2. So theta by 2 means somewhere in this direction we will have that net force. I hope you all got some idea on this model. Now just look at this example. If you are given the same equilateral triangle with three charges at three corners, all are identical charges. Suppose all these are Q, Q, and Q. In between a charge Q is placed. So what is net force on this charge means, due to first charge, that force, all the corners will be at same distance, and this force will be in this direction F2, and this force will be in this direction. So all forces are of same magnitude. So F1 will be equal to F2 will be equal to F3, that is kq square by r square, where r is the distance from any corner to the center. If I draw a horizontal line like this, if this angle is 30 degrees, this angle will also be 30 degrees, so that this will be F cos 30, as all are identical, I am assuming that as F. This will also be, if this angle is 30 degrees, this angle will also be 30 degrees. So we'll have F cos 30. So cos components gets cancelled. For the same forces in this direction, we'll have 2F sin 30. 2F sin 30 is nothing but 2F into 1 by 2. So 2 gets cancelled. This force gets cancelled with this. So net force on the charge at the center will be 0. Net force is 0. This is true only when all the charges are identical in magnitude as well as in sign. Then only we can solve this kind of questions. Then just look at this one more example. If instead of three charges, if they gave four charges at four corners of a square, all are identical charges. And they are having side length A. What is net force on charge at any one corner? I'll assume this as first one, second one, third one. On this fourth corner, this first one will exert a force in this direction, let that be F1, and 3 will exert a force in this direction, let that be F3. And as side length is A, F1 and F3 will have same magnitude, that is KQ square by A square. I assume this as F, and this will be in a direction according to alpha is equal to theta by 2, as the angle between them will be 90 degrees. That resultant of 1 and 3 will be square root of f square plus f square, which is a root 2f, and it is directed at an angle alpha is equal to 90 by 2, which is 45 degrees. So that will be in this direction. This is f13, and now f2 will also be in the same direction. So this is f2 also. This diagonal length is root 2a. So f2 will be k q square by root 2a square, root 2a whole square, or that will be k q square by 2a square, or which is f by 2. Now this f13 and f2 are parallel, so that the net force will be equal to f13 plus f2, that will be root 2f plus f by 2. I can take f by 2 as common, so that this will be 2 root 2 plus 1, that is equal to k q square by 2a square into 2 root 2 plus 1. So this kind of questions with 4 charge system also you can expect. And the same question they will ask you like this also. If suppose they gave like this, there is a square, charges which are placed at diagonally opposite corners are identical, and this q will repel this charge, and these two charges will attract. That means charge at first corner and third corner are attracting, and charge at second corner is repelling. If this system is in equilibrium, if the system is in equilibrium, then if the system is in equilibrium, then find q by q. They will ask you to find q by q. In that situation, this f13 will act in this direction. F2 is acting in this direction. F2 we got that as k q square by 2a square, whereas f13 will be k q by root 2 k q by a square. So F2, as it is in equilibrium, F2 must balance with F13, so that k q square by 2a square will be equal to root 2 k q by a square. So q gets cancelled. A square gets cancelled. We'll have q by q will be equal to 1 by 2 root 2. With sign, if I am speaking, I have to keep a minus sign, because if one charge is positive, the other two charges are negative. So now these are some models based on Coulomb force. Now we'll discuss one interesting application, the effect of medium. Effect of medium. If two charges are separated by a distance r naught, q1 and q2 are the charges, then the force, if I'll write f naught, that will be 1 by 4 pi epsilon naught q1 q2 by r naught square. Now, if the two charges were placed in a medium by same distance q1 Q2, the two charges were placed by same distance in a medium. Then this force will be F, that will be equal to 1 by 4 pi epsilon R epsilon naught into Q1 Q2 by R naught square, where epsilon R is relative permittivity or dielectric constant of that medium. So F I can write like this, F naught by epsilon R, which is less than F naught. So if medium changes, then net force will decrease. So now they will ask you what is the distance between the two charges in that medium, so that find the distance or new distance between the charges in the medium. So force in medium is same as force in free space. So now no longer the distance is R naught. We changed the distance in that medium to a new value R. So now that force, whatever force we are getting, that force is same as the force in free space. So F dash is equal to F naught. F dash will be now 1 by 4 pi epsilon R epsilon naught Q1 Q2 by R square. That will be equal to 1 by 4 pi epsilon naught Q1 Q2 by R naught square. So 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught gets cancelled, Q1, Q2, Q1, Q2 gets cancelled. So epsilon R square will be equal to R naught square. So from this R will be equal to R naught by square root of epsilon R. So this is the new distance between them, or else they may ask you what is shift in that distance. That shift will be R naught minus R, so that will be R naught into 1 minus 1 by square root of epsilon R. You can find some good number of questions based on this. And similarly, we are having one more interesting example based on this same. Just look at this example, or this is one interesting application. If suppose you are given, there are two charged pendulums, both are having same charge, so that they will repel, identical strings, length will be same, and if this distance is r, this will experience electrostatic force in this direction, and weight will act in downward direction. Tension in the string is T. So if this angle is theta, this angle is also theta. So the tension we can resolve like this, T cos theta, and in this direction we'll have T sin theta. So here first they will ask you to find angle. For that I can balance T sin theta with electrostatic force, which is K q square by distance square, and T cos theta we can balance with mg, that is weight of that object. So if I divide this first equation with second equation, I'll get tan theta, which is Fe by mg, or else you can write like this, kq square by mg r square. So you'll have some good number of questions based on this angle. And next they may ask you to find tension in the string. For that we'll square and add these two equations, so that t square into sine square theta plus cos square theta will be equal to 1. Will be fe square plus m square g square, or from this tension in the string will be equal to square root of fe square plus m square g square. Similarly, if suppose from this pivot point, this point or this plane is at a distance y, I can write the tan theta, one more interesting application, tan theta as opposite side will be r by 2, by adjacent side will be y, that is equal to, we are having k q square by mg r square, or from this we'll have y is proportional to r cube. So we'll have some questions based on this. So y2 by y1 will be equal to r2 by r1 whole power of 3. So if suppose that pivot point is decreased by a distance half, then what happens to new separation between the charges? For that kind of questions, you can use this. And the next interesting point based on the same application is, if the system is moved to gravity free space, or any artificial satellite, then G will be 0. If G is 0, tan theta, which is Fe by mg is there, that becomes infinity. That is possible only when theta is 90 degrees. That means the two strings becomes perfectly horizontal, so that the two charges will become perfect in a horizontal plane, the two strings, so that this angle will be 90 degrees and this angle will also be 90 degrees. And electrostatic force only exists here, and that balances with our tension force. So that what is that electrostatic force, they will ask, that is tension, which is 1 by 4 pi epsilon naught, two charges q square, by distance is 2l, because each string is having length l. So that it will be 1 by 4 pi epsilon naught q square by 4l square. So this kind of questions also, this is one PYQ asked in NEET, and sometimes they ask in JE also. An interesting question, what is tension in the string, they will ask, or else what is force between them and what is the angle between. And one more additional point on this application is, if this system is placed in a medium of dielectric constant epsilon r and specific gravity Sg. I hope you all know specific gravity means density of the object by density of water. We'll call that as specific gravity. So the same setup we placed in a fluid medium or in some medium. Now these two charges, say as medium changed, both Coulomb force will change, because Coulomb force will be equal to Fe by epsilon r, and gravitational force according to Buoyancy force, that apparent weight will be equal to mg into 1 minus 1 by sg. So both will change, so that that angle will be no longer theta, it will be tan theta dash, that will be equal to Fe dash by mg dash, or that will be equal to Fe by epsilon r by mg into 1 minus 1 by specific gravity. So now the same I can write like this, Fe by mg by epsilon r into 1 minus 1 by specific gravity, or from this tan theta dash, Fe by mg is nothing but tan theta, which is in our free space, by epsilon r into 1 minus 1 by sg. So this is relation between angle between the two strings in a fluid medium to angle between the two strings in free space. And here we are having one interesting frequently asked model based on the same. If theta is equal to theta dash. Then what happens means epsilon r will be equal to 1 by 1 minus 1 by Sg. If suppose the same, they can ask like this. If Sg is given as 3, so that epsilon r will be equal to 1 by 1 minus 1 by 3, or this will be 2 by 3, which is in turn becomes 3 by 2 or 1.5. This kind of questions we can expect based on this. So this is one interesting application. That's it for this video. I hope you all enjoy. So just practice all those models. And my suggestion is like this. If you are listening this video, along with that video, just try to write a rough synopsis notes. Then you can understand very easily whenever you can revise that. So that's it for this. Have a great time. Please subscribe Profile Progressive Physics Learning. Have a great time.